Hi, in this video I'm going to solve out this limit. It's the limit when x approaches to 4 for this expression here. Now, again, we have to start by checking out if by substituting the x as a 4, we will get an undefined. And just evidently here in the denominator, if we substitute this x by a 4, we get division over 0. And if we substitute here this x as a 4, we get inside the root here a 16. And the square root of 16 will be a 4. So we will get here as well a 4 minus 4 in this denominator. So we will end up having this 0 over 0 are undefined. That is to say that we have to check it out through algebra in order to find a way to skip this undefined. So let's get to it with the limit when x approaches to 4. And here we'll have the 4 minus x plus 12. And the denominator will get as well the x minus 4. Now, in order to work this through, I will have to multiply what's in here in the denominator by its conjugate. So I'm going to do it in here. I'm going to use different color just to sign out and multiplying by the conjugate. It will be 4. Now, instead of writing this negative, I'm going to write this plus here. And the rest remains the same. I'm only doing the conjugate for what's in here, the denominator. So it will be over 4 plus the square root of x plus 12. We have to do it this way in order to be, if we multiply, this will be just the same multiplying by 1. So now I'm going to write here with a different color. Let's say I use this blue here. If you multiply here, this a minus b times a plus b. So this is plus b. You will get in return here a squared minus b squared. And that's what I'm going to do here. I'm going to multiply here, so it will be the limit when x approaches to 4. Now this 4, which will be this a squared, it will be a, we have to square this, so it will be a 16 minus, now the square of this square root, we will get just only this, what's inside will be x plus 12. Now we have to be careful with this negative sign here, so that's why I'm using the parentheses here. It will be all over, and here we have to multiply these two here. So I'm getting here the x minus 4 times 4 plus the square root of x plus 12, like this here. Now, from here, we just have to take away this the negative sign here by multiplying by x and then plus a 12. I'm going to continue down here. So with the limit when x approaches to 4 for 16 minus x minus 12. And I'm getting in the denominator x minus 4 times 4 plus the square root of x plus 12. We close the parenthesis here. We can simplify this out. Again, I have to write this limit when x approaches to 0 to 4. So here we get a 4 minus x in the numerator, and below I have a x minus 4 times the square root of 4 plus, I'm sorry, here it's times 4 plus the square root of x plus 12, just like this. Now notice something here. This 4 minus x, just switching signs with this x minus 4. So if I multiply this by a negative 1, I could get through this quite nicely here. So I'm going to do it down here. the limit when x approaches to 4. I'm going to take away this negative sign here. So we get here x minus 4, just switching signs all over. Oh, this is too ugly. Would be x minus 4 times the 4 plus the square root of x plus 12. There we go. So now here we can cancel out this x minus 4. I'm going to cancel out in here and here, and we get to the limit when x approaches 4 of a negative 1 over 4 plus the square root of x plus 12. Now that we cancel out this x minus 4 from the previous step, we have to try out substituting the x as a 4 in the expression to see if we get an undefined. We can just see that we won't get an undefined. Just we're going to substitute here right away in here. Sorry, we're running out of space here. So substituting the x as a 4, we get a negative 1 over 4. I'm going to scroll down this a bit just to make more room. Here, okay. So we'll get a negative 1 over 4 plus the square root of 4 plus 12, and now we get this 4 plus 12 would turn into a 16, and the square root of 16 would be 4. So I'm getting a 1 over 4 plus 4, and I'm getting at the end, as a result, negative 1 over 8. And that would be just basically it.